Hello dear students. Today I'm here with one of the topic of class 10 and the topic name is real numbers. This is a very important chapter from the board point of view as in the last 5 years I have analyzed the paper and I have seen that from this chapter they have asked 6 marks question most of the time out of the 80 marks. So let's start with the topic. We are going to just quickly brief about some of the concept which already have studied in the earlier years. So here first we'll talk about some different type of numbers. So first we'll talk about natural number. So we know that natural numbers are those numbers which is a counting number as 1, 2, 3, 4, 5 and so on. These numbers are known as counting numbers. Next, once you include 0 in that counting numbers, that means if you include the natural number and 0, then the number is called whole numbers. In those whole numbers, if you include the negative of counting numbers, then that is called integers, which is denoted by I or Z. Whole numbers are denoted by W and natural number is denoted by N. In that case, if you go further, then we have another type of number which is not integer, is known as fraction. Collectively, the integer and fractions makes rational number, which is denoted by Q. And if you combine the rational number along with another type of number which is irrational number, then we get real numbers. Now real number, again we know the definition of it, a number which can be written in the form of P by Q, where Q is not equal to 0 is called rational number, whereas a number which cannot be written in the form of P by Q, where Q is not equal to 0 and P and Q are integers, is known as irrational number. So in this one we are going to study about two specific type of numbers which is a part of real number is rational numbers and irrational number. Real number is denoted by capital R. So before we start with the actual topic, two more type of number we must discuss. In that, one of the number is prime number. So if you talk about prime number, so prime number are those number which has exactly two different factors. So we can say a number having exactly two different factors is known as prime numbers. In this case, we know the prime numbers. For example, we have 2, 3, 5, 7, 11, etc. Remember, 1 is not the prime number. Next type of number is composite number. So composite numbers are what? A number having more than two different factors is known as composite number. For example, we can take 4, 6, 8, 9, 10, etc. So these are some of the basic number which we must know in order to proceed further about the real number chapter of the class 10. So now we'll be moving towards the content which we have to study and based on which the question comes in the board exams as well as in the other part exam in the 10th class. So in that The first subtopic is fundamental theorem of arithmetic. So fundamental theorem of arithmetic states that every composite number can be expressed as the product of primes and this prime factorization is unique apart from the order in which it occurs. So what is the meaning of order being meaningless? What it may mean is, suppose if you are writing a number 12, so we know 12 we can write it as what? We can write it as 2 into 2 into 3, or we can write it as 2 into 3 into 2, or we can write it as 2 into 2, or we can write it as 3 into 2 into 2. So see, in all the cases, as product is commutative, their order doesn't matter. So that's what it means when it is saying that the prime factorization is unique apart from the order in which the prime factors occur. Now, how we are going to use this concept when it comes to the question? So this concept will be used for a few of the concepts like finding LCM, HCF of two or more numbers, and also to understand that whether a number can end with the digit 0 or not. So how we'll find the LCM and HCF of the number? So for that, LCM we'll find by taking the product of highest power of each prime factor of all the numbers, and HCF will be product of least power of common prime factor. So what we need to remember here is, when it is about LCM, we take highest power and we take each prime factor into the consideration. Whereas when it comes to the HCF, then we take least power and we take common prime factor. That means if we have two or more numbers, then whatever factor will be common, only those factors will be considering and will take least power of it. So once we know about the LCM and HCF of two numbers, one relation we need to study which comes based on LCM and HCF of two numbers. So the relationship what we need to study between LCM and HCF is LCM into HCF equals to product of two numbers. Remember, this relation is valid only for two numbers. It is not applicable for more than two numbers. So these are some of the points which we need to study to discuss our first exercise. So now let's move towards solving of the questions, where we'll be seeing that how we can solve the questions. So the first question what we can see here is, the question is find the LCM and HCF of 140 and 156 and verify that the LCM into HCF is equals to product of the two numbers. So when we have to find the LCM and HCF of the number, the first task what we have to complete is we need to prime factorize the given numbers. So as the numbers are 140, so if you prime factorize 140, this is will be divisible by 2. It is 72. It will go 35 times. It will become 5. With 5 it will go 7 times, and with 7 1 time. Now if you take 156, we can divide it by 2. So it will go 2 7 times 14 and 2 8 times 16. Then further we can divide it by 2. It will go 39 times. Then it will be divisible by 3 13 times, and 13 1 time. So we got the prime factorization of 140 as 2 square into 5 into 7. And the prime factorization of 156 is 2 square into 3 into 13. Now if I have to find out LCM of these two numbers, then we know LCM, in this case, we have to take all prime factors and the highest power of it. So first prime factor will take 2 and its highest power is 2. So it is 2 square into. Next prime factor is 3 and its highest power is 1. Next prime factor is 5 and its highest power is 1. Next is 7 and into 13. Now if you multiply, it will come 4, 4 into 3, 12, 12 into 5, 60. So this will be 60 into 91, which will be 0, 6 into 1, 6, and 6 into 9, 54. So this is our LCM. Now let's find out the HCF. HCF will be the product of least power of common prime factors. So for that we can see, as in these two numbers prime factorization, only 2 is the common prime factor and both is having same power, so we'll take that power only as the power, and the value of HCF will become 2 square, which is 4. So this is how we are going to find out LCM and HCF of these numbers. Next we have to verify. So let's verify it. So in the verification, if you will take LCM into HCF, what we'll get? LCM is 5460 and HCF is 4. If you multiply it, you will get 4 into 0, this is 0, 4 into 6, 24, carry 2, 4 into 4, 16 and 2, 18, carry 1, 4 into 5, 20 and 1, 21. Now let's find out the product of the numbers also. So if I'll take product of numbers, that will be 156 into 140, which when you multiply, this will be 14 into 6, 84, carry 8, 14 into 5, 70, 70 and 8, 78, carry 7, 14 into 1, 14 and 7, 21. So as we can see here, these two values are same. So we can say that therefore LCM into HCF equals to product of two numbers. Now let's move to the next question. So the question says, check whether 8 raised to n can end with the digit 0 for any natural number n. So how we are going to approach to this question? Let's see. So when such question comes, first of all we'll find out the prime factorization of base. So here in 8 raised to n, if you'll write the prime factorization of 8, it will be 2 into 2 into 2. And we know that if a number has to end with 0, then both 2 and 5 should be the prime factor of it. So we'll write for a number. So what we can say here is, in this case, as we know, if 8 is equal to 2 into 2 into 2, then if I will take 8 raised to n, then this will be 2 into 2 into 2 raised to n. And now from this, from the uniqueness of the fundamental theorem of arithmetic, we can say that there is no factor in 8 raised to n other than 2. And we also know that for a number to end with 0, 2 and 5 both should be the prime factor of it. In this case, as we can see, since 5 is not a factor of 8, therefore 5 is also not a factor of 8 raised to n. And so therefore 8 raised to n cannot end with the digit 0 for any natural number. I hope it is clear to you. Let's see the next question. This question also is very important, as many times the question has come based on this concept. So let's talk about this question, which says explain why 7 into 11 into 13 plus 13 is a composite number. So to solve this type of question, we will take 7 into 11 into 13 plus 13. Now we'll see that here 13 is a common factor between the two terms. So if we'll take 13 as common, we'll get 7 into 11 plus 1, and it will become 13 into 77 plus 1, which is 13 into 78. If you want, you can further write it as 13 into 2 into 3 into 13. So as we can see, it is product of primes. So by fundamental theorem of arithmetic, we can say that 7 into 11 into 13 plus 13 is a composite number. So this is how we are going to solve this type of questions. Now let's discuss some more question, because till now we have seen how to find out LCM and HCF when numbers has been given. Now we'll try to find out when we don't have the number, rather than it is in terms of unknowns. So in this question, it is given that the two positive integers a and b are written as a equals to x cube into y square and b equals to xy cube, where x and y are prime numbers. Then find HCF and LCM of a and b. So here we have a equals to x cube into y square and b is xy cube. We know that when you have to find out HCF of AB, so HCF of A and B, it will be what? It will be the product of least power of common prime factors. And we know here x and y are prime. So this means they have already given us a number as the product of powers of prime. So in this case, in order to find HCF, let's take common factors. So here both x and y are common. And the minimum power of x is 1 and the minimum power of y is 2. That means the HCF will be xy squared. And if I want to find out LCM of A and B, then LCM says that it is a product of highest power of each prime factors. So your prime factors are x and y, and the highest power of x is 3 and the highest power of y is also 3. So our LCM is x cube into y cube. So this is how we are going to get the answer of these type of questions. Now, next question, what we are going to solve is again of another type, which says find the largest number which divides 70 and 125, leaving the remainders 5 and 8 respectively. That means we are looking for a number which divides 70 by leaving remainder 5, and when you divide 125 by the same number, it will leave the remainder 8, which means that that number divides 70 minus 5 exactly, and also 125 minus 8 exactly. So what we can say here is, in this case, the required number will be equals to, it will be the HCF of 70 minus 5 and 125 minus 8, which will be HCF of 65 and 117. Now we have to find out the HCF, so let's prime factorize it. The prime factorization of 65 will be 5 into 13, and the prime factorization of 117 will be 3 into 3 into 13. So as we can see, between these two numbers, the common prime factor is only 13. So that means HCF of 65 and 117 will be the product of least power of common prime factors, so which will be 13. So therefore, largest number is equals to 30. I hope it is clear to you, and this is how we have solved this question. Let's talk about how they can give what type problems. So here the question is given that on a morning walk, 3-person steps off together, and their steps measures 40 centimeter, 42 centimeter and 45 centimeter respectively. What is the distance each should walk so that each can cover the same distance in the complete steps? What we can understand here is that between 2 points, one person takes 40 centimeter step, other person take 42 centimeter step, and the third person take 45 centimeter steps. Now there should be a point where these three people should be again together, and that should be the first instance what we are looking for. So for such type of questions, whenever it comes that what should be the minimum distance it should cover, we are going to find out the LCM of the given numbers. So if you'll talk about LCM, in order to find LCM, we'll have to prime factorize the given numbers. So if you'll take the prime factorization of 40, we can write it as 2 cube into 5. 42 can be written as 2 into 3 into 7, and 45 can be written as 3 into 3 into 5. So now if I want to find out the answer, we'll have to find LCM of 40, 42 and 45. We know that LCM is the product of highest power of all prime factor. So here prime factor is 2, whose highest power is 3, into 3. If I will talk about the highest power of 3 is 2, so this is 3 square, into 5 where the power is 1, and into 7. So now if you multiply, this is 8 into 9 into 5 into 7. So 8 into 5, that will be 40, and into 9 into 7, 63. If you multiply it, it will be 0, 4 into 3, 12, carry 1, 4 into 6, 24, and 1, 25. So it will be 2520 centimeter, which implies this should cover 25 meter and 20 centimeter distance in order to meet again and cover the distance in the complete steps.